Hello everyone, today we are going to solve some important conceptual advanced physics problem from JEST 2024 physics. So let's start. The first question is that an infinitely long cylinder of radius capital R has uniform volume charge density. A spherical region of radius capital R is carved out of it as shown in the figure, and that is the figure. At what value of small r, this is the small r, the radial coordinate of cylindrical system is the electric field maximum. Okay, so to find out small r, we need to find out E1 and E2. What is E1? E1 is the electric field with cylinder of length small l. From Gauss law we can find out E1, and electric field due to sphere of radius capital R is this E2. Using Gauss law we can also find out E2. Okay, so to find out net electric field, that is E1 minus E2. Okay, that is the net electric field E1 minus E2. And to find out maximum electric field at a distance smaller from the center of the cylinder, we need to take the first derivative of net electric field with respect to smaller and equate with 0, and from this calculation we can find out smaller. Okay, and then second question is that two trains each having length capital L0 are moving towards each other with same speed v but in opposite direction. So basically two trains T1 and T2 are approaching to each other. Both are moving towards each other with same speed v, okay, but in opposite direction as measured by an observer in an inertial frame. Okay, so what is the length of one train as measured by an observer in another train? Okay, that is basically question from relativity. Okay, so relative velocity of T1 with respect to T2 is this ux prime. Here ux is equal to u and v is equal to minus u. From this equation we can find relative velocity of T1 with respect to T2, and from length contraction rule we can find out the length of one train as measured by an observer in the other train. Okay, and that is the rest of the portion is just calculation. Okay, so here L0 root over 1 minus ux prime by c r whole square. Okay, not v by c r whole square. That is important. We need to find out relative velocity of T1 with respect to T2 and need to substitute this ux prime here. Okay, that is the main trick here. Okay, then a classical particle undergoing a simple harmonic motion is confined to region minus a to plus a on the x-axis. Okay, if a snapshot of particle is taken at a random instant of time, what is the probability that it would be found in the region a by 2 to a? I think that is the good question. Okay, that is the good question. So from statistical mechanics and quantum we need to acquire the knowledge of quantum mechanics and statistical mechanics here. Okay, so to probability of finding the particle from x to x plus dx is that px dx, that is 2 dt by capital T. Capital is the time period, and for simple harmonic motion as here they wrote down that in the question undergoes simple harmonic motion. Okay, classical particle is undergoes simple harmonic motion. For simple harmonic motion v is equal to this. Okay, omega is the angular velocity, and from this equation dt is equal to dx by v, and first we can substitute v from this here. A is the amplitude. H particle, it is given that particle is confined to a region minus a to plus a. Okay, on the x-axis. So to find out probability that particle will be found in the region a by 2 to a, we need to integrate from a by 2 to a, and that is the rest of the portion is just mathematics, but concept is important. Okay, rest of the portion is mathematics, but to find we need to acquire the knowledge of quantum mechanics and classical mechanics here to solve this problem. Okay, and we need to find out the px dx, the probability of particle from x to x plus dx, that is px dx to small dt by capital T. Capital T is the time period. Okay, then okay, it is another question. The speed distribution of molecule of an ideal gas in equilibrium at inverse temperature is found to obey Maxwell distribution rule. Okay, particularly to obey Maxwell distribution rule. M is the mass of molecule, C is the normalization constant. Compute average of v to the power 4. Okay, to find out average of v to the power 4, as C is the normalization constant, we need to normalize it also. Okay, we can calculate V4. Expectation values of v to the power 4, not V4, sorry. Expectation values of v to the power 4 is this. Okay, and just we need to use gamma function integration. Okay, 0 to infinity to the power minus x to the power n minus 1 dx is equal to gamma n. Gamma n is equal to n minus 1 factorial. Okay, you need to use it, and we need to be careful to solve it. Okay, and the rest of the portion is just calculation, but you need to practice it by yourself. Okay, and you need to use gamma function integration. Okay, so next question, I think that is the final question. A magnetic vector potential is given as that. Find out the corresponding outgoing magnetic flux through the 5 phases excluding the shaded one of the unit cube with one corner at the origin. Okay, we need to find out the magnetic flux v dot ds, but we need to exclude this shaded surface portion. Okay, as in the question they are giving magnetic vector potential, we need to find out B magnetic vector. Sorry, they are giving magnetic vector potential. We can find out magnetic field B is equal to delta cross A. From this equation we can find out B, that is I cap 3 minus 2I z. And one thing, I have done a mistake. Basically here there will be no closed integral. Okay, as in the question they mention that we need to, for flux, we need to find out the flux excluding this shaded surface. Okay, without this shaded surface, so there will be no closed loop. So it is my mistake. There will be no closed loop in the integration. Okay, basically we can give the answer without any without any writing. Okay, so we can just tell the exact answer. Basically in magnetic vector, magnetic field, basically B is the magnetic field and A is the magnetic vector potential. Okay, in magnetic field there is I cap present, so for integration v dot ds, and there will be no closed loop also. I have already mentioned it. So for these two surface 1 and 2, I have also written for these two surface 1 and 2, area vector is present along plus y cap and minus y cap. So there is only I cap present. So b dot ds will be 0 for these two surface. Okay, and for this surface area vector is present in k cap. So there will be again phi 0 for this surface also. I have also written that, and we need to exclude this surface to calculate flux. And for these two surface at x is equal to 0 and x is equal to a, I think a is equal to 1 here. For x is equal to 0 and x is equal to 1, for this x is equal to 0 surface, y and z fixed and area vector present in minus I cap. Okay, as y and z is fixed and x is equal to 1 surface, basically one plane. Okay, area vector is oriented along plus I cap, and x is equal to 0 surface, area vector is oriented along minus I cap. So from again x is equal to 0 and x is equal to 1 plane, we can find out phi. Okay, and again phi from this x is equal to 0 and x is equal to 1 surface will be 0. Okay, so total flux, magnetic flux except this excluded surface also be 0. So answer will be 0. So good. So time to progress, and bye.